Hello. So for exercise number 9, we will use the webcam. So we will get data from the webcam and manipulate that data in openFrameworks. So I will open the project generator and I will point it to the folder that I've been using to store my examples or exercises. And I'm going to call this exercise 9 VideoGrabber. So basically this is an adaptation of the VideoGrabber example that comes in your built-in openFrameworks examples. So I'm going to open in openFrameworks. So what kind of code do we need for this exercise? So we need to go to documentation, and in the video package we have all VideoGrabber, and we're going to use quite a few code from this class. So we're going to init grabber. So basically this sets up the grabber to be used. Then there's something called update that updates the grabber on frame rate. So video classes need to be updated so that the frames get updated, that they don't get stuck. And then there's draw. We're going to draw the VideoGrabber information in the draw function. Also, we can get the height and the width to draw the manipulated version. We need to emulate this size, and that can be useful for us. So what we're going to do is go to H and create a new object of the class of VideoGrabber. And I'm going to call this my VideoGrabber, for example. Okay, so in CPP, in setup, we can say VidGrabber, no, my VideoGrabber init grabber, and then we specify the size of the grabber that we will use. So let's use some kind of standard resolution for our camera. I'm going to use VGA values. They're quite manageable. It's 640 by 480. That's the standard VGA resolution, right? Great. So we've initialized the grabber, and now in update we can update the my VideoGrabber update, right? And now we can draw it. My VideoGrabber draw. Right, so now we can, oh, I have a typo here. I need to specify the coordinate. So I'm going to draw it in the top left corner. So let's run it. So what we should get is myself in the window of our openFrameworks application, right? We're gonna get a warning about using the camera. So the openFrameworks or Xcode will ask you permission to use the webcam. So that's what is going to happen. So while it's compiling, I can actually show you the examples, video examples. So these two are very useful. VideoGrabber, which is the one we're doing, basically a version of that, and then Video Player. It's more simple, but quite useful as well. It teaches you how to, it shows you how to play video files and manipulate video. But the manipulation here is more like a playhead type of manipulation in this example. I find the VideoGrabber a bit more interesting because it also allows us to discuss textures, which is something new for us, and I'm going to talk a little bit about textures. So in the previous exercise, we got pixel information to draw. We use that to draw geometry, right? Circles and squares. In here, we're going to use pixel data to create new pixel data, right? And now that we have succeeded with our build, I'll recap my explanation of textures in a short while when we create the textures. So VideoGrabber would like to access the camera, okay, and there you go. You have the image that my webcam is capturing, which is me in my living room. Great. So we have the basic thing going on, which is the video feed. But now I want to have another image next to it with some processing, that I manipulate the pixels and do something with it. And a very basic manipulation is to invert the pixel value. So if we take the pixel value and we use 255 minus the pixel value, we always invert it. So if the colors are 0, 0, 0, they will become 255, because 255 minus 0, and vice versa. If the colors are 255, they'll become 0, 255 minus 255. And all the other colors will become the complementary colors, and that's how we invert, right? So what do we need to invert? We need a pixel object, a pixels object that will, of pixels, that will store the pixels that are being manipulated, and then we need a texture to draw the pixels. So we've taken a look at the pixels class previously, so it's in the graphics module, right? So that's the pixels of pixels class, but the texture class is in the GL. It's a GL OpenGL class. So it's part of the OpenGL. And what is the texture? So the texture, it creates textures that live on your graphics card from bitmap data, so from pixels, and they are kind of the twin sister kind of the of pixels. So if we check the of pixels definition, we see that of pixels is an object for working with blocks of pixels. Those pixels can be copied from an image that you've loaded. That's what we did in the previous exercise. Something that you've drawn using of graphics, so you can put graphics into pixels, or get it from the VideoGrabber, which is what we're going to do, right? So what is the difference between pixels and why do we need both pixels and texture? So pixels is kind of the data, the mathematical data from the visuals, right, into pixel format. Whereas the texture is the actual canvas where you draw the pixels in. So the pixels live in the CPU, in the central processing unit, and the textures live in the GPU. So they go to the draw function, and it's what you can draw. You don't draw pixels directly. Pixels, you store the information of the pixel data in the pixels, but you then draw the pixels inside a texture, right? So that's what we're going to do. We need the pixels object and we need a texture object. So I'm going to say of pixels, this is going to be my inverted pixels, because that's what we're going to manipulate. And then of texture to draw those pixels, and it's going to be my texture, okay? Okay, so now in CPP, we're gonna initialize the pixels. So in the previous exercise, we didn't have to initialize the pixels because basically we used get pixels. So if you use get pixels, the pixels get initialized, the pixels object gets initialized. It will know the size of what you want. But in this case, we're creating new pixels. We're going to be creating new pixels. So we need to set up the pixels object, and we set it up with the allocate command. We can check that actually. Allocate. So basically, you set a pixels object with width and a height and a type of image that you want, and it can be grayscale, color, or color and alpha. So 8-bit, 24-bit, and 32-bit kind of pixels. If you're getting pixels from an image, it will know, the object will know. When you do get pixels, it will know what kind of image it is. But when you're creating from scratch, as we are, we need to set it up. So we're going to say my inverted pixels dot allocate, and the size will be the width of the VideoGrabber. So we can say my VideoGrabber dot get width, right? And the height will be the my VideoGrabber, and this is getting long, so I'm gonna clean up some space. My VideoGrabber dot get height, right? And then the type of image is a constant of pixels RGB. It's down here. Okay, we're working with RGB color, so it's going to be of pixels RGB. So we're using actually this code here, the pixel format. But it's the same logic, RGB or RGBA and monochromatic. So it's the same kind of logic as I explained before. Okay, so we're allocating. So we're creating a pixel object of the same size as my VideoGrabber, right? Now for the texture, so the my texture, we're going to allocate, but here we allocate directly the pixels object. So my inverted pixels, okay, and then the texture will get all the needed information from the my pixels objects. It's already configured here in the above line. Okay. So now in the update, what we're going to do, remember, we're working with the pixels, so it's a mathematical operation. We don't need to draw yet, because we don't draw the pixels, we draw the texture. So in here, I just want to get the pixels from the grabber. So I will use another pixels object to get the clean pixels, and then I'm going to use the my inverted pixels to invert them. Okay. So let's do this. I'm going to create here of pixels a new pixels object. I'm going to call it my pixels, and this will be my VideoGrabber dot get pixels. So it's the same get pixels command we used in the previous exercise, right? Then we need a for loop to go through these pixels and to invert them. Okay, so the pixels object has a function which is size, and here we go. It gives you the number of values the object contains. So, for example, in RGB, you have 400 by 400 by 3, right? Because RGB has 3 channels, so it's the number of pixels times 3. That's the amount of data, and it's interleaved. It's R. The first value will be R, the second value will be G, the third value will be B for each pixel, right? But you don't need to know this, because if you invoke size, that will be calculated by default, and you can imagine pixels as, imagine that your image is going to be flattened in something two-dimensional. It becomes something one-dimensional, and that's what my pixels is. So we go through a for loop, which goes from 0 to I lesser than my pixel's size. Okay. And then it goes pixel by pixel, so I plus plus. So if you wanted to go channel by channel, it will go 3 by 3 in an RGB interleaved kind of image pixels from the image. So we have the for loop set. So for each of these pixels, the inverted pixels will be my inverted pixels will, and here we need the pixel is like an array, right? My inverted pixels I equals 255 minus my pixels I. So we're going to go pixel by pixel, and we are doing this mathematical operation to invert it, and then put the result into the my inverted pixels. Okay, and now we put the inverted pixels into the texture, and we draw the texture, and that's it. Okay, so my texture, how do we put pixels into a texture? So there's a load function. Sorry, let me go documentation, GL, OpenGL, and then we have texture, and we have load data, loads the pixels, it loads pixels data into the texture. So that's what we need here. My texture loads data, and the data is basically my inverted pixels. Okay. So let's recap what we're doing in update. So we're updating the VideoGrabber just to make sure the frames don't get stuck. Then we're putting the VideoGrabber data into a pixels object, local one, just by doing the get pixels. Then we're sweeping through the pixels. The image, which is a 2D image, gets flattened into a one-dimensional kind of pixel mathematical representation, which is an array. And then we go through that array, and we put those values into an array which is of the same size. Which is the inverted pixels one, and we do this operation, this mathematical operation. So any processing of the pixels would go in here, and we're doing a very simple processing of the pixels, which is to invert them. And once we've done that, we load these processed pixels into a texture which we previously set up in OVAP, right? In OVAP setup, right? And now we can draw the texture, my texture draw, and we draw it in which coordinates do we draw it? We draw it after we draw the first grabber image, right? So this is my video grabber dot get width, right? Then we can draw it also in 0, and then we need a width and a height for the texture. Or maybe it can be without the width and the height. I think because we've defined the size, I don't think we need the width and the height. So to draw, we can draw it with a certain width and a certain height, or just draw it without it, I think. So let's see if this works. If not, I'll just add the width and the height. So that's basically it. So now the second image is probably going to be go out of the screen. So then I have to go out of the window. So I probably have to rescale, to resize my window. Yeah, there we go. It's a little bit too small, but you get the inverted feed in the right side, right? So what I would do is my main, I would say that this gonna be 1080, sorry, 1280 by 480, right? Then we get the two images side by side. I hope. Okay. There we go. And that's it for this exercise. I mean, we could do a lot with this image. Again, we could have geometry being done. We could have colors being captured from the webcam. We could do a lot with this. And in the update, we can retrieve a lot of stuff, and that we could put there. But that's up to you now to explore if you want to use webcams for your projects, for example, if you want to play with it. And that concludes our exercise.